Hi, my name is Andy Ray. I built a tool called Shaderfrog, which I want to tell you a little bit about, but I also want to tell you about my nights and weekends project I'm working on to improve Shaderfrog. So, the reason that I built Shaderfrog in the first place was I was making a game where you're a bubble that moves around the screen, and I wanted to design the background shader. And I had this idea in my head. I wanted it to have some light rays and sort of a watery pattern. So, what did I do? Well, I went to online shader repositories and I found shaders that looked, sort of like a noisy water pattern, and shaders that looked kind of like light rays. And I took their source code and I combined them together by hand into a new shader, and I used that in my game. And what I wondered was, could I build a tool to do this by hand? And that's where Shaderfrog came from. So just to show you briefly what it does, you can see we have a graph editor over here. And on the left, we have the two shader nodes. And it's important to note these are the full raw GLSL source code of the shaders. There's no metadata about them. Um, they're really just full shaders. So let me drag this one into my output node, and you can see it built the sort of the noisy pattern, and then I can drag in the light rays. And what Shaderfrog just did here was it built a third shader. It doesn't use render to texture or any intermediary steps. It parsed the two input shaders and compiled a third new shader that adds them together. And this solved my problem for the game, but where Shaderfrog doesn't really work is when you want to import this shader into an existing 3D engine. So Shaderfrog is built on top of Three.js, but you can't really use Three.js lighting information in this output shader. And the reason for that is this is using the raw static input GLSL source code here, but Three.js builds its shaders at runtime. And if you have programmed shaders, you understand why you have to do that. We won't get into it here. But what I really wanted to do was find a way to be able to use, Three.js lighting information and fog information and vertex animations and things like that. So that's what this new project is. So let me show you the API I'm developing so far. So I'm making a new material here, and this wraps a 3 mesh Phong material. These are the parameters that are passed to the mesh Phong material. These are the uniforms passed to the custom Shaderfrog shaders. And what I'm saying is I want the albedo, which is sort of how much light the object reflects, to be an addition of those rays in that noise shader. And just briefly, the noise shader, again, is just the full shader program. It's not anything special, no metadata. It's just the full raw GLSL source code. And then when we go look at that running, we can see, so I'll tell you what we're looking at. The left item is a raw mesh Phong material, and we have a light here in the scene. And the right is the Shaderfrog running shader. And you can see it's properly applying the lights to the shader. And in fact, I can prove it a little bit. We can go change the color of that point light. So red, red, green, green, blue, blue. So this should be a green light. We'll wait for this to reload. And you can see it's now properly applying the new light color to the shader. So this, in theory, should work with any sort of Three.js material, like a mesh Phong material or a Lambert material or a PBR material. And if you think a little creatively, you might be able to see some other use cases about this. So this API is not final, but I just wanted to show off the new capabilities of this Shaderfrog tool. I would love to hear your feedback. This is all experimental. I don't know what the end product of this is going to be, but I'm really happy with how far I've gotten. Okay, my name is Andy Ray. Go check out Shaderfrog, and thanks for your time.